So we'll review for the exam as long as you want to. If there's questions, we'll answer them. And then with whatever time we have left, when we run out of questions, if any, we'll continue talking about functions. But number one thing, I want to make sure everybody feels confident and ready going into Thursday's exam. We've talked about it a couple times already. The topics are posted. In terms of format, I did add one thing. We had a great question in office hours about context and where they fit in. I hadn't explicitly called them out under type checking, so I added that to the list. I did not update the announcement in Canvas, but they're in the class notes. So I did explicitly call out contexts now in this list because those are fair game for exam 1. The format, I've mentioned this a couple times, there's a handful of true-false questions. Any definitions that we actually took the time to put in the class notes are probably a good study guide for true-false questions. Then I have 3 exercises, I think. Yeah, only 3 exercises. So handful of true-false questions, 3 kind of short answer exercises where I give you a little snippet of code and ask you questions about it using the interpreter stuff we've been talking about. So 2 of the exercises are related to that. One of the exercises is going to be extending your language. So probably the most important thing we've talked about this semester is how do you add new functionality to a language, and that's your acronym. So you'll need to know how to define the concrete syntax, the rules for it, evaluation and type rules, abstract syntax, a type of method, and evaluation. You don't have to write code, you don't have to write Haskell, unless you want to, you're welcome to. But as long as you can give me pseudocode or describe behavior, that's good enough for me. So that's the format, that's it. There shouldn't be anything surprising. My goal is not to trick anybody. We were just talking right before this in my office about how much I dislike exams, and if it were up to me, I would have each of you come visit in office hours for a few minutes, and that would be your exam. But we just don't have time for that. So you have to have something, but my job is to teach you, not be mean to you, not try to trick you. So I don't think there's anything on there that would be surprising, but that's what today's lecture is for, so you guys can ask the questions. Let's see what else. I'm usually really generous with partial credit. If you get to a question and you have no idea what it is or what it means, write something. Write whatever is in your brain at that moment. Here's what I'm thinking, and I'm stuck. If you put that on the paper, that's better than nothing. The worst thing you can do is not put anything. And I'll, of course, be here during class, so you can come ask questions if there's something about the wording or something you don't understand. I will be here to help, at least somewhat. Let's see what else. Other questions about the exam before we jump into topics? Yeah. No, not required. The question was, do we have to give justification for the true false? Nah, not unless you want to. So if you're on the fence and you're thinking, this is true if, write it in the side notes. I will take it into consideration, but it's absolutely not necessary. Yes?
We don't get a cheat sheet, right?
No cheat sheet. Yeah, closed book, closed notes. You're not going to need it. I really don't think you're going to need it. Even the true false over some of the definitions are not, I think for the most part, stuff you would just know. Or stuff I would hope you would just know. Again, not trying to trick you.
How good does my draft need to be?
How good does what?
How good does my draft need to be?
Your giraffe. I thought you said draft. I was like, draft of what? Your giraffe, yes. Drawings of giraffes are welcome. See previous lectures. If you weren't here for those lectures, you're lost. Maybe not, you're lost. topic list that I sent you, I mean, that's it. If you know what's on here, you're golden. And another good question came up in office hours about, how in depth do I need to know these topics? And I would say the exam is pretty comparable to how long we spent on something in class. So if you think about parsing, we hardly talked about parsing in class, so don't expect any questions on parsing. On the other hand, we've talked about substitution and bind until we are all sick of both. So expect questions on substitution and bind. Those will for sure be on the exam. And then of course adding new functionality to the language. That will definitely be there. Okay. I don't think I had, another thing I was going to mention, don't worry about memorizing the constructors in the various languages, AE versus ABE versus BAE. If I give you a language, I will tell you what's in it. So you don't worry about memorizing any of that. That's not necessary. I think that was it. Don't practice writing Haskell code. That's not time well spent. Trying to think what else has gotten asked. Oh, points. So somebody did ask about how I give points. I think I denote it in your exam, how many points each question's worth. So if you want to be strategic about your time or where you're worried about getting the most points, it's given to you. And then again, if you give me something, the chances of you getting at least a point are a lot better than giving me nothing. And I'm generous with partial credit, so write something. Yeah.
Are we gonna have to write the evaluation rule things?
Yes. Inference rules. Absolutely. Yes. And remember, we wrote those for both evaluation and type check. So know the difference between them. Don't worry about the specific syntactical elements. So for evaluation, we use the double line with the arrow at the bottom. If you use some other symbol, just tell me what it is so that I know. But don't worry too much about the specific syntax. As long as you can get the logic across, that's all I'm concerned about. What else? Nothing? Oh, okay, yes.
I guess this is not about the exam. This is more specific question about the material.
Yes.
So for crate, when we define that,
Yeah.
obviously the concrete syntax, rules, abstract syntax, and then it's type, and then it's evaluation.
Yes.
So in every case, we're defining evaluation rules and type rules. Is that correct?
Yes.
I guess
Yep.
the first rules are the evaluation rules, and the second rules are the type rules.
Yes.
And then for the evaluation, so can that kind of depend? Because I know when we built type systems, our evaluator was kind of evaluating a type.
Mm-hmm.
And when we built evaluators, our evaluators were actually doing evaluation. So I guess does that final acronym, can that just does that depend? In evaluation, are we always evaluating, or could we also be doing just outputting the type, which is technically?
Oh, I see what you're saying. So when I say evaluation, I mean our eval
Actual
method.
evaluation.
Yeah, the actual execution of the code.
So if we're, I guess, for our types, when we define type of,
Yep.
that was just kind of its own thing, as in we just use the type rules to define, I guess,
The
type of.
behavior,
But we're not
yeah.
actually doing evaluation. in terms of
Right.
crate.
It's part of the larger interpretation of the language, but it's not the actual
It's
execution
kind of a
the
middle
code.
step, I guess, between type rules and evaluation.
Mhm. Yep, it's just a form of static analysis,
Okay,
the type
makes sense.
inferences. Just like when we wrote optimize, and we wrote a predict method, those were all
Right.
static analysis functions. But when I say eval, that last letter of the acronym E, that's the actual execution of the code.
And then, so I guess, even if you're not defining, let's suppose you're creating a language that doesn't have a type checker, you still want to write those type inferences, just so, I guess.
If I ask for them.
Okay, right.
Yeah, I'll be explicit
Okay.
on the exam. Yeah. Good question. What else? Yes.
This is also a little specific, for like the type inference and static type checking. Like, it's the one you did in class, like the type of method, static type checking, and then type inference, is it just like a together?
Sort of. So type inference is all we've done so far in this class. The difference being type checking, which is where we would explicitly assign a type to a term. We've never done that. So in our type of method, we're actually inferring what the types are. We're saying if you hand me parameters of this type, then I'm inferring that the result is going to be this type. But we're never explicitly saying this parameter is an integer or this parameter is a Boolean kind of thing. So all we've really implemented is type inference in this class. And your previous comment about static type checking, that's absolutely true. So the type of method that we wrote, that's a form of static type checking or type inference.
So then like when we run it in the command line, or like you run in GHCI, it's always like plus and then num 3 plus num 3 and then num something else. So that you're telling me it depends and not unless it will run.
But num could have been any word we chose, right? So that's just a constructor in our language. We could have picked blue and said that's how you create the notion of an integer in our language is by saying blue 5 or blue 4. We just happen to choose the term num as our constructor. So there we're not really assigning a type. We're just saying this is a thing in our language and it happens to be called num. Does that help? Does that make matters more confusing? Remember, we decided what the abstract syntax was, right? So we came up with the name num and the name plus and the name minus. Now they happen to mimic what those things actually do in our language, but we could have called them anything. We didn't have to use those terms. Good question. What else? Yes.
Can we go through another example of using our acronym to like add something to the language?
Yeah. Let's do it. Let's do an example of adding something to our language. I'll put it above this here. There we go. What do you want to do?
Let's have matrix operation.
Matrix operation? Is that what you
I'm
said?
joking.
I don't want to do. I don't know that I can do that. How about I'm trying to think of something that hasn't been on a previous exam or project that maybe you've already got your hands on. That would be a fresh example. How about like not bool or inverse? So if I hand my constructor false, it returns true. If I hand it true, it returns false. Just a good operator, right? So, oh, hold on, I lost my notes. Lost my spot in my notes. It's like clicked on the wrong thing. There we go. Okay, so let's do, what do you want to call it? Bang? Use the bang symbol. So we'd have to go through and define each of our elements. So concrete syntax first. I'm just gonna say bang T, I guess, for my concrete syntax. So again, if we were doing, let's make it a little bit more formal here, so I don't risk confusing people. So if I have some language that's got all the things in it that we've previously had, the new term that I'm adding is, we'll call it bang T. Yeah? Okay. What's next? See our rules. Let's do rules. Let's do type rules first. So, I need to say something about bang T. Bang T is of type what? Okay, we know we gotta get to T-bool. What do I need to know up top? Anything?
T is of type bool.
T is of type T-bool. Are we done?
Yeah.
Question?
Can you just say T is of type, sorry, bang T is of type T is G?
Bang T is of type T. You mean little t or big T? Well, little t is a term, so little t is not a type. And I'm in my rules, so remember, we would take these rules and implement type of.
Right.
So we want type of to return something of the data type that specifies the types in my language. So if I did little t, because little t is of a different data structure, that would be confusing, I think. What if I wanted to add a context in? What would I do?
Gamma.
Gamma. What do I do with gamma?
Gamma derives T just on both of them.
Easy. Easy peasy. So we could, yeah, if I'm looking for you to add gamma, I will say it in the exam. I don't know who asked that, but good question. Okay, are we good? Questions over that? That's it. That's the type rule for bang. Let's do eval rules. So now I need to say bang T evaluates to something. We don't really know what yet. Scroll this up a little bit.
What is that? Haskell uses a tilde, right?
For not, for negation, yeah, I think it does. So Haskell, I believe, it's, why is that not showing up?
I think it's just a function called not.
Oh, it is? Okay.
Well, we're gonna use that. Actually, let's do this. We'll just say that, the not operator, whatever that equivalent is in Haskell. I don't know what, I can't think off the top of my head. What it uses. So negate of T. Is this right though?
No,
No. Why is this not right?
we need a value on
We
the
need
bottom.
a value. So get rid of T. We'll leave the negative there for now. So what how do I get a value?
On top.
I think I heard it.
On top, T evaluates to some value.
Yes. So let's say T evaluates to some value. And then down below, we say this. Yeah? Question.
Would it be equal equally correct to do this in a slightly longer way and say if t is false, then on the bottom it goes to true, and then write a second one for true when it goes to false?
Yep, sure could. So you could write a couple of rules and say, well, let's say t on top, t evaluates to true, then I know down below it's gonna be false. And then write a second rule for that. You can also do, I mean, not that I'm trying to talk you into writing more than you have to, but another way we could do this is, so if I said up top that t evaluates to some v, and then not v is equal to v prime, then down below I would say bang t evaluates to v prime. Right, so I could put all my logic up top and then just have a value on the bottom too. So lots of ways to write the rules. And if you can give me one, we're in good shape. But do make sure you fully capture the behavior. So if you're writing the true, false cases, make sure you include both. Sorry, I cut you off. Question?
Do we need context for normal inference rules, or is that just for type rules?
Context is for type rules. An environment
Oh,
for
that's what I mean.
evaluation. You could. We never did that in class. We didn't go through the exercise of saying that the environment derives
But
this
it's
behavior.
the exact same notation?
It
though?
would be, yeah, and honestly, I wouldn't worry about it. I'm not gonna be looking for it on the exam. It's not something we did together in class. So no need to include it here. As long as you know what an environment is and what a context is, I don't think I explicitly ask you to use them in your rules on the exam. Yes?
The concrete syntax says t goes to num, right? So does that like violate what we're doing? Because we're trying to do like a bool thing, right?
In the concrete syntax, it says t goes to num. That's just defining what terms exist. So we're saying in our language, if you remember, let's find a case where we've done this recently. So I cheated and didn't write the whole thing, but this is what we've been doing all along. Where it can be num, true, false, t plus t, t minus t. So all I'm saying down below is that I'm gonna extend this and add in the bang case. So this is now a new option within our language, which you're right, means we could, from concrete syntax, put a num in there, but then that's why we need our rules, is to say, well, that's not actually valid. Yes.
Would it be right to say that the concrete syntax is what we see before parsing, and then our abstract syntax is what the computer knows to do with after parsing?
Yep.
Okay.
Absolutely, yeah. If you remember on project 1 where I had you use the parser, that's all it does. Converts concrete syntax into abstract syntax, and that's it. Yes, Golub, I saw your hand up.
Yeah, it was kind of his, I was just gonna ask, so the concrete syntax is only applicable when we have a parser.
Right, yep, yeah. Yeah, I wanna know that you can extend your language and add concrete syntax to it, but converting between the two, I'm not gonna ask you to do that, or write any, I'm not gonna ask you to write a parser, on the exam, or ever in this class. Had you use one, you don't have to write one. Okay, that's it for email rules. Any other questions over these? I had somebody ask about axioms, and do you guys remember what an axiom is?
It's just, isn't an axiom like the smallest assumption that you make?
Yeah.
That it is always true?
Right, it's always true. So when we wrote our inference rules for values, there was nothing on top, right? That's an axiom. You don't need to make any assumptions for this thing to be true, it's just always true. That's all an axiom is. Okay, what's next? Abstract syntax. What's that gonna look like?
Data, something.
Yeah. Assume we have some language. You still see this? Not very well. So all I'm interested in is what we're adding. So it's got all of our other terms already in it. What would I add for Ben?
What are we gonna call it?
Do what?
What are we gonna call it?
What are we gonna call it? I don't know. What do you wanna call it?
Bool? Not bool? I don't know.
Not bool? I like that. We call it not bool. What does it look like? This is just for the abstract syntax. So this is how you would construct this term in your language.
So it's a single operator, so lang to lang.
Lang to lang. Is that what you were gonna say? Does that make sense? So remember, when the languages we used were AE, ABE, BAE. So just replace lang with one of those, and it would look like code we've already looked at before. Again, I will give you the language that you're extending, so I will tell you what the name of the language is, and you would just plug it in there for your abstract syntax. Yeah.
Is the only time I guess we're gonna use something other than lang or other than TAB is when we're defining new types?
Yeah, new data structures in your language, yeah. So the only time we've done that so far in class is when we've created a new language or we've created a language over types, right? Because we needed a way to represent tnum and tbool, so we created a new data type for that. Yeah, don't worry about being able to create data types again. I'll give you those. I just want to know that you can use them. So not bool, I'm going to hand it something in the language, and it's going to give me back something in the language. Or that's how you make it a part of the language. We've got to give it a term, and then it is itself a term. Could we have called it bang?
Sure.
Sure. Could we have called it blue? Yes. Doesn't matter what you name it. Call it whatever you want. But I need to know how it's constructed. Sam? All right. C-R-A-T. We gotta write type up. So again, assume we already have our type of method. It's got its signature, and all the other cases are defined. So all I'm adding is type of not bool, some term. What do I do? So imagine it's Thursday, and you hit this point on your exam, and you're blanking. What do I do?
Fold.
Bolt? Is that what
Fold.
you said? Oh, fold. I was like, don't run. Fold. When in doubt, fold.
I like your answer too.
Don't run. So we gotta push type of inside, right? I'll add the correct syntax. But again, if you leave out the do statement, I'm not gonna take points off for that. So show me the logic or describe the logic. You don't have to write actual code. I'm gonna write code because that's what we've been doing, and I think it's easier. What do I know my term needs to be? Oh yes, question.
That's what I was gonna say. Do you have to check if T is a bool before returning anything?
Let's do. Makes our life easier, right? So we know it's gotta be, or we want it to be a bool. If it's not, we wanna fail. And what's left?
Well, we should store it in a T prime, right?
Do we need to?
Oh, we're just type checking. Oh, yeah, no.
Return T bool.
Is that it? Yeah, question?
Kind of while we're on that, at the right top, the type of double code, could you go over when that would be maybe? And when it would?
Oh, yeah, it would, so in this case, it would be maybe, because it can fail, right? So if I handed not bool a number, that first line right there would fail, so we know it's gonna return a maybe. Yeah, so ours would be, what, lang to
T lang.
maybe T lang, we'll say, was our type language. What if I wanna, well, let me pause, other questions? Yes.
And we still have to define data T lang as well for this to work, right?
Correct,
Okay.
yeah. If I was actually implementing this in code, I would expect there to be a data T lang where we've got all of our types, tnum, tbool, any other types that we would want. Yes,
And then if we had to extend the method like type double eval, I assume you would give us the signature, right? Or would we have to come up with that?
yeah, I don't think I give you any signatures, because I don't expect you to write any code. So just, as long as you can either in this exact syntax or in words or something tell me, hey, first I would need to check the type of the term, make sure it's a Boolean, and then I would return the whole thing as a Boolean. That would be a perfectly acceptable answer. Or you can write a do statement, or you can write pseudocode. It doesn't really matter to me. But yeah, I don't think you even need a function signature. If you get into the exam and you have a question about what I'm expecting a method to return, just ask me.
That's good.
What if I wanted to include a context? What would I change? Assume we have some gamma.
Just have to add another argument to the type of.
Anything else? Done. That easy. Doesn't change anything for this operator. Yeah.
What exactly is the point of putting it there if it doesn't change anything?
Because if we had bind in our language, maybe that T is an identifier and I need to look it up. Or maybe it's some, more complex term that I would have to go look up an identifier in my context to find out the type of. So that's the only reason. Fold, because we have to fold it through. Other questions? Put your hand up.
This is just a general Haskell question, but what is the difference between the type keyword and the data keyword?
It's just another way to construct an element. And I think under the covers, there's probably a lot happening there in terms of how Haskell interprets them. I tend to use data when I'm constructing more than one thing. It's an actual structure, whereas like when we create our environment and our context, that's really just a list of things. And I want to denote it as something that I want to keep track of, but it's not, like an entire structure of terms.
Okay.
So that's why I use type for for gamma and environments in the code.
Okay.
Any other questions over typo? Okay, let's do eval. Last one. On to evaluation. What's this gonna look like? What's the first thing you would do?
Not put T in there inside of the eval, right?
Not full. Say that again?
Need something after the not full in the eval.
Oh, yes, I do, thank you. Needs term, that would help.
Are we doing environment in this one as well?
You wanna do environment? Okay. Let's do an environment, why not? Sounds like fun. You're gonna hit this point on Thursday. My mind is going blank. Fold, always fold. You're stuck, is that what you were gonna say? Or you have to
We need a signature.
say it again?
We need a signature.
Sure. We'll throw a signature in there. You guys are being so proper. It's gonna take an environment, an element of lang, give us back a maybe lang. We'll say it can't fail. Okay. Yes.
If call evaluate on T and map that to T prime.
Evaluate T. And I'm gonna assign that to T prime.
Make sure it's a bool in there.
Okay.
Oh, wait, are we assuming that we've done the type checking or not?
Yeah, it doesn't hurt to throw it in there.
So I guess like on the exam, if we have to define an evaluator, will you just specify if we have to type check as well or not, or is either one fine?
I don't even know that I specify. I leave it up to you.
But
I'm
like
not
either
gonna
one's
take out
fine,
points.
right?
Yeah, either one's fine. Yeah. If I don't explicitly say, use an environment and implement dynamic type checking, it's fair game. You do what you wanna do. Let's see, so we did, okay, so now I've evaluated my term and I'm making sure it's a Boolean. What's left?
You would return just and then bool of T inverse, or T prime inverse.
Boolean, I'm gonna use bang because I don't know what else to use.
It's not. In
It's
Haskell,
not?
yeah. There aren't prefix operators in Haskell.
Oh, it is not, isn't it? Okay, well, I'm gonna do it this way here so I'm not further confusing people. Since you don't have to write actual Haskell code on the exam.
Adjust as well before that, right?
The return takes care of it.
Yeah, return takes care of just.
Oh, it does,
Yep.
okay.
Yes,
Isn't the exclamation mark in our language?
it is,
Okay.
but I imagine that's also how Haskell does it. It's not, it uses the not word, so let's do this. Not in, oh, that didn't help either. The Haskell version of not is what would go there. I should have picked a different example. Okay, does that get us? We're missing one thing. There we go. Is that what you were saying too? Yeah. Good catch. All right, there we did it. We extended our language to have not bool. And we did all of the things. Concrete syntax, rules for both evaluation and type inference. Abstract syntax, we wrote the type of, what we would have to add to type of, to implement our new operation, and what we would have to add to eval to implement our operation. Felt good. We did that fast, sort of. Except for syntactical problems. So if you can do that, you're in great shape. Now, I'm not gonna give you not bool, but it will be the exact same steps for something else. Any questions over what we just did? Okay, awesome. All right, what else you wanna talk about? We still have 30 minutes. Yes,
Can you go over, from however many lectures ago, the inference rules for bind?
inference rules for bind, yes. Evaluation or type?
Evaluation.
Where are you? Those are type. Here we go.
Still type.
What'd you say?
That's still type.
Is this still type? Yep, still type, thank you. I was almost there. Here we go. There it is. All right. So infant rule for bind. I'm not gonna ask you to write this, by the way, but knowing how it works is important. So this was our rule when we were doing direct substitution, right? So not necessarily the notion of an environment in here. And what we're saying is, on the bottom, it's just our term. The same concrete syntax we would use to construct the term if we were writing it in our language. So our bind with an identifier equal to some term in a body, in the scope of the bind. And we need to know that that evaluates to some value. The way we know that is by making a couple of assumptions up top. So we've got to know that that term that we're binding to the identifier, one, we need to know that it will evaluate and give us a value. So that's what V's of t is. All I'm saying is, the rule we've written for evaluating our bind is we're going to force it to evaluate the term first, the term that's being assigned to the identifier, get a value from that, and then all we do is substitute that value in for I in the body of the bind. And if I can show this piece, and then using that gives me a value, which is V sub S, so that's whatever the substitution evaluates to, then I know I can find a value for my bind statement. So really, evaluating a bind is whatever the body of the bind evaluates to with the identifier substituted in. And that's it. Does that help?
Yeah, I think I was just a little confused on the syntax. So the sideways arrow just means that you're replacing I with V sub t.
That was that. Remember when we first talked about substitution? When I first started confusing everyone, it was way back here. Remember this day? When we talked through these? So this is the notation of substitution. I'm going to substitute I with V in V. So then when you see that notation in the inference rules, that's all it's denoting, is substitution. Yeah, good question. And let's look at type just for fun. Type of bind. There was eval. This was prior to contexts. So can I get them both on the screen? No, I can't. But notice how similar the inference rule for determining the type of a bind is to the evaluation of a bind. So same thing on the bottom, just now I know it's going to be of some type, the type of the body, and I get that by first checking the type of the value that the identifier is assigned to, and then substituting it in for I in B to get some other type, and then that's the type of my whole bind statement. Questions? Yes.
I guess kind of moving on for that, can we go over the substitution function for, I guess, specifically the if state? Like
Yes.
when we did direct substitution.
Substitution over if. What is that? Did we have it?
Up, it's up. It's past that, right there.
There we go. Oh,
I
we
guess
didn't
over
have-
bind, that's what I meant.
Oh, over bind, okay, yes. So, remember, in a bind, the somewhat interesting scenario with binds are we have to watch out for shadowing, where we redefine the same identifier, right? And so that's the only kind of tricky case to watch out for. So in our substitution function, all that means is we need to check the identifiers, right? So if the identifier I'm trying to substitute for is the same as the one I'm encountering in my bind, then I don't push it into the body, right? Because we know that there's a shadowing situation happening. If they're different, then I can substitute to my heart's content. So folded inside to the body of the bind. But if those identifiers match, then I have to pause and I don't want to keep substituting into the body. You remember in the examples we walked through, I think there's one in here somewhere, where we said when you get to the in statement, which denotes the body, down here, is this where they are? When you get to the in statement, that's where you would stop, because that defines the scope of the next bind. Sorry, I cut you off.
Oh, no, I was saying that your example was a little bit over. Where you said like, you touched it out with it.
Oh. Yeah. This one has a different scoping. I don't think it has a, well, it does have, no, there's one, yes, so here's a shadowing example, where I bind X to some value here, and then I'm gonna bind X again, so X gets shadowed essentially by the inner bind. Which means in our definition of substitution, we have to check for that case. The best advice I have for wrapping your brain around substitution of bind is just to walk through a couple examples. I know it's tedious, it's a lot of syntax, but until you kind of walk through the behavior, it's hard for that to fully click. Other questions? Let me go back to the exam list, topic list, see if that works better. I think we've talked about largely everything on this list already.
Should we remember the language properties section? Like the completeness, determinacy, normalizing?
It wouldn't hurt. Those perhaps make good true-false questions.
Would you mind going over the, what those mean again?
Sure. Where were those at?
Somewhere in there.
Somewhere
Pretty
in
high
here.
up.
Yeah, they're like all the way up.
That was way early on, wasn't
Right
it?
after inference systems and semantics.
So before,
Keep going.
keep going, keep going, keep
Right
spinning.
above where you first defined the cray acronym.
Oh, yeah, that was really early. Here we go. Completeness, this is what you're talking about?
Yeah.
Yeah, so just completeness, knowing that eval has a case for every term in your language. So if I had 5 constructors, but I'd already defined evaluation for 4 of them, that's not complete. That's all you need to know in terms of completeness. Determinicity, I mean, that's important. We've talked about that several times. That we're gonna have one value, unique value for our input, right? We need to know that our interpreters and our evaluation are always gonna result in the same thing, given the same input. And then normalizing that it's gonna terminate, that we're not gonna hit a case where we just keep evaluating. A couple of you have seen this on projects where, I think it was in Optimize, where I think you started to define the optimizer and you did the cases that I called out. Optimize if you're trying to add t with 0 and then the if statement, but then you did like a catch-all case where you had optimize anything else is equal to optimize of that thing. So like optimize x equal to optimize x, and you just got stuck in a loop. So that would not be normalizing, right? We'd never get to a value there. That's all those properties mean. Good question. What else? Go back to the list. We have so many notes. Sheesh. Only halfway through. Let's see, we talked about, we've already done an example with concrete and abstract syntax. We talked about parsing, and that's really all you need to know with parsing is what it does. Inference rules, we've already seen example for both eval and type. Difference between values and terms. We haven't talked about that in a minute. What's the difference?
Atomicity?
What's that?
Atomicity?
Pretty much. Values are already evaluated to their base form, essentially. They're not gonna change by continuing to evaluate them, where terms would. Identifiers and substitution, finding identifiers to values, using substitution in evaluation, so in your interpreters, environments and deferring substitution, that's important. Scoping of identifiers, that's important too. Remember those bind examples that we walked through in class, reviewing those would be a good thing to look back over. I think that's about it for bind and substitution though. Type checking, difference between runtime and dynamic. Static type checking and type inference, that your discussion question on project 2, if you've already answered that and can look back at what others have said, that's, I mean, you guys are nailing it there, the difference between the two. We have really only implemented type inference in class. We already did type inference rules, context we've talked about, and then we just did this last piece together for a new constructor. So I think we've largely talked through everything that's on the exam. I'm trying to think of any questions I asked that maybe we haven't already talked about today. I can't. Any other questions? Okay. Well, you know where to find me. If you turn in a project between now and Thursday, I'll try. I'll do my best, but I'm not making any promises. If all that have been turned in thus far, you've gotten comments back from me. So you guys should be in good shape, but I mean, tonight and tomorrow, I will do my best. I will be checking email though, so, you know, shoot me questions. If you want to hop on a quick Zoom call, or if you want to stop by my office, just let me know. And I'm always happy to talk. Okay, what do we have? We have a few minutes. Let's talk about functions just a little bit more. And the reason I'm pushing on new material is I'm trying to get you guys some class time to do your final project.